This is Solution Stoichiometry Part 2. In this case, we're going to be looking at a redox titration, in particular one that uses potassium permanganate. This gives a very deep blue color, which is then reduced to the colorless Mn2+ ion, so it's a self-indicator once the reaction has exactly reached completion. In this case, we have a dilute sample of acidified dilute iron 2 chloride, that's where we're getting the Fe2+ ions from, is titrated with 0.102 molar of the potassium permanganate. We're looking at just the participating ion there, until the color of the permanganate ion in the solution no longer is apparent. This required 31 mL of the dilute potassium permanganate, so we need to figure out the concentration of the iron 2 chloride number. So first of all, let's write down everything we know to try to give us an idea of how we're going to attack this problem. So this is everything we know. We know we have 0.500 liters of the FeCl2 solution. And ultimately what we are looking for is the concentration of the iron chloride solution, which means that what we're going to have to find out, if we're already given liters, is what we really need to get to is the moles of the iron chloride solution. So in order to get there, we're going to need moles of the iron 2 chloride. Now, we are also given that we have 0.03100 liters of the potassium permanganate solution. And we know that the concentration of this was 0.102 molar. What we're going to do is we're going to use this information here to determine the moles of potassium permanganate. So moles of the potassium permanganate equals molarity times liters, which is the 0.03100 times 1 times 0.102 molar. When we go through this calculation, we find we have 3.162 times 10 to the negative third molar potassium permanganate. Now we have the moles, should be moles. Now we have the moles of the potassium permanganate, and we should be able to find the moles of the iron chloride and then get to the molarity. So let's go ahead and do this. We have 3.162 moles times 10 to the negative third moles of the potassium permanganate. We're going to use the balanced chemical equation up above. So there's 1 mole of potassium permanganate is actually required for every 5 moles of the iron 2 chloride solution, which means that 1.581 times 10 to the negative 2 moles of the iron 2 chloride are present in the solution we have of the iron 3 chloride here. So we're going to take the moles, 1.581 times 10 to the negative second. We're going to divide it by the volume that we have. So we have 0.0500 liters. And the final answer ends up being 0.316 molar iron chloride. Our final answer is limited to 3 significant figures because we have the 0.102 molar potassium permanganate. So although I carried these out beyond 3 significant figures, our final answer should only have 3. You do not want to round your answers until you get to the very final calculation. That's why all of these were carried out to 4 figures and then round when I get to the final answer.